when you plug these x's in for x, the y's should have been, let's see, is this 4, 5, 6, and 7. Did anybody get that?
I did.
Okay. On this one, we had to multiply by a half, so the whole numbers, or the prime numbers, aren't going to be very helpful, but. So this gives me a negative half plus 2, which is 1.5. 0 times a half is 0. 0 plus 2 is 2. A half times 1 is just a half. 2 plus a half is 2.5. A half times the 2 gives me 1. 1 plus 2 is 3. Are you guys understanding how we filled those out? All right, last thing I think that we'll get to today is let's graph one. The way we're going to graph these, I'm going to make my table up and down. If you like yours to the side, that's fine. We're going to pick 4 numbers to put into our x's. We get to pick them. If you don't like negative numbers, don't use negative numbers. I don't mind -1, so I'm going to do -1, 0, 1, and 2. You are welcome to use any 4 numbers you want. If you get them too big, though, you might run off the graph. So when we graph, we pick that number. We pick it for x, and then we find out what we get for y. So now we're just doing what we did prior. We're going to plug these numbers into the equation. You don't have to write this out every time, but I'm going to put in a -1, a 0, a 1, and a 2. These are going to be my points that create the line. And does not matter what points you chose, you will have the same line, maybe just different dots or points, but it would all lie on the same line. So find your solution when you plug your x in. Find out what y becomes. When you have them all solved, now you have points, x comma y, and graph it. Graph your points. If you want to check on Desmos to see if your line looks like theirs, that's not a bad idea. You just type in y equals negative 2x plus 1. I'm going to graph mine, and then you can check yours once you have yours.